All right, so this is just a quick organic synthesis video. I just want to briefly talk about how we can synthesize polysubstituted compounds from an aromatic ring, from benzene in this case. And so it's really not terribly difficult, although a lot of people get overwhelmed with it. I certainly did when I started this unit. But I'd like to make this video just to give you a quick method to get these synthesis problems done quickly without spending like 6 hours on one, because certainly we all know that's possible. So what I do first is I look at each molecule here that's attached, each substituent. And we've got 4 in this case. We've got an amino group and then 3 carboxyl groups. So what I like to do is I like to look at what we need to synthesize and attach each one of these. So for the amino group, we'll start with that first. What I actually like to do is begin with a nitro group. Again, nitro is an NO2, right? And then what we'll do is we'll add that hydrogen and knock off that oxygen so that we get our desired amino group. That's probably the easiest way to synthesize this substituent and to add it to the benzene ring. So we'll start with that. How do we get that amino group added to it? So, again, we have to start with our nitro group. So how do we get a nitro group? All right, well, we know that we're going to need, so I'll put NH2 here. We're going to need a couple of things. We're going to need nitric acid. We're going to need sulfuric acid, and that will get us our NO2. So I'll put that down here. That's going to give us our NO2, okay? And then what we have to do is we have to take palladium on carbon, as well as hydrogen gas, and that will reduce NO2 to become NH2. So that's how we get this NH2 here. Okay, how about the carboxylic acids? Well, what I like to do is I like to start with an alkane, then use some potassium permanganate to turn the alkane into the carboxylic acid. And so it's a very simple Friedel-Crafts alkylation, and then what we're going to do is we're going to take the potassium permanganate and chop off the carbons, with the exception of the first one, and add on that double bonded oxygen as well as an OH group to that. So what we need for these, just want to add in here some ethane. And so what we're going to do is we're going to take, it'll be chloroethane, so it'll be a CH3 CHCl. Okay, so we're going to add those substituents here, here, and here. Okay. Now that will give us our carboxylic acid, because after that, all we'll do is we'll react it with potassium permanganate, like so. And that will produce then what we want, which is a CH3 C double bonded O OH. And that will be what we see here, COOH. Okay, so now we got to think about the order that we add these substituents. Remember, there are para-directing, there are meta-directing, and there are ortho-directing. So typically, there's a ortho-para-directing substituent, and then there's a meta-directing substituent. So we have to figure out, are these, each one of these, ortho-para or meta-directing? Remember, we have 3 positions. We have ortho, para, meta. So if we're referring to this amino group right here, then the following carbon, so this carbon here, as well as this carbon here, would be considered to be ortho. 2 carbons down, so if we're talking about this carbon here and this carbon here, that's meta. 3 carbons down or directly across the benzene ring, we're talking about para. So remember that if you have a para-directing, let's say NH2 here, this is an ortho-para-directing substituent. So if we were to add this first, then we would only be able to add the following substituents in an ortho-para fashion, meaning we could only add to the second carbons or the third carbon directly across. So that's kind of what we would have to do. Now for that, we need to look at the order in which we can add all the substituents while still making it work, meaning that we don't violate any of those directors and what they want. Okay, So we could add the alkane here. And if we were to add the alkane to any of these three positions, then that alkane would actually be an orthopara director. Okay, so if we add here, then we could add the amino group because that would be ortho, that would be ortho to the carboxylic acid. We could add it here and then add the amino group, okay? But the amino group is also orthopara. So maybe we could add this alkane, and then we could add the amino group. The problem is, if we did that, then that alkane is there. Again, that's an orthopara director, the amino group, but then we've got to add this one here, which would be another alkane. Again, that's also orthopara directing, so we could do that, and that would be totally fine. And then we could add this one here. So that would work out. You could do it that way. You could also start with the amino group and then add your alkyl substituents here. So there's a variety of ways that you could synthesize this molecule. For the purpose of this video, what we're going to do is we're going to add the amino group first. All right, so again, the first thing we have to do here is we have to add that amino group, which will require, again, nitric acid and sulfuric acid. So we're going to write those in. NO3, as well as H2SO4. Okay, so when we add that, then we get NO2, like so. Okay, so NO2 here is actually a meta-director. So that wouldn't be good if we just left that and finished it later with the hydrogenation. So let's go ahead and hydrogenate it. We'll add in some H2 gas, and let's do platinum on carbon, like that. And what that'll do is that'll give us our NH2, like that. Let me move the camera over here a little bit. That'll give us our NH2. So now what we have to do is we have to add in our alkyl substituents. So we'll go ahead and do that. In the presence of aluminum chloride, we will go ahead and add in our CH3, CH2. Actually, let's make it this. It's going to be CHCl here. That chloride will pop off, and that will allow the CH3CH to attach here, and we'll have an alkyl substituent. So what that will look like then is like this, and that will have NH2 there. And then remember that when we add this, we have to consider, is it ortho, para, or meta-directing this NH2? Well, we know it's ortho and para. So what we're going to do is we can only add it here, here, or here. For the sake of this synthesis, what I'd like to do is actually add it down here. And you may be asking, well, let me erase that real quick. You may be asking, how do I know that that needs to be added there? Well, we could add it to the sides, and that would be fine. The problem is later on, we'll find a little bit of a clash between the ortho and para versus the meta-directing substituents. And so if you were to do the problem that way, you would discover that. For the sake of time, we'll add it down here, and we'll make this CH3CH2 group, an ethyl group. Okay, but now we've got that on there, and we've got to convert that into a carboxylic acid. So let's go ahead and do that. So potassium permanganate is one of our reactants here. And so we're gonna add that in, and we'll have an NH2. And down here we've got our carboxylic acid. Okay, so that is kind of the step there that we need to do first, as far as adding our carboxylic acids. Now what we'll do is we'll do the same thing 2 more times. So we'll add in our alkyl chloride. We'll add that in, alkyl chloride there, and that will go to the ortho position. We'll use potassium permanganate again. Then we'll add to the ortho position on the right side of the molecule. With the alkyl chloride, we'll do the potassium permanganate oxidation again. And then what we'll do is we'll have our synthesized molecule. So the molecule again is going to be, it's going to be like this, COOH. And it's going to have our nitro amino group here. So it's really not that difficult. You know, it's just about prioritizing the steps. So I hope that was helpful.